please welcome to the stage Lucie Martinol from On.
Thank you, Paul. This was a proper introduction. So good morning, everyone. It's a pleasure for me to be here today. And I'm going to take you through two very exciting projects that On has in the pipeline. So for the one who are not familiar with the brand, On is born in the Swiss Alps 15 years ago. The purpose was not to bring another running brand, but to throw away the standard model and to make something better. So we believe in experimentation, innovation, big and wild dreams, trying, failing, learning, and trusting that there is a better way forward. So the first project we have is called ta-da! Clean Cloud. So for the one who have never seen the shoe, I guess I've seen few shoes around, but the midsole of the shoe is very specific. It's made out of holopods, and those holopods, we call them clouds. So in that case, we are trying to manufacture them in a cleaner way, and that's why we call them, the clean clouds. So the journey started with Borealis back in 2022. The first 5 kilo of EVA, ethylene vinyl acetate, were made, and we made 5 pairs of shoes from that. So there was 2 years from the proof of concept to the supplier agreement, and then 2 years more to bring the shoes to the market. So ethylene vinyl acetate is the main polymer we use in midsoles, and in that case, it's the ethylene part that we make out of carbon emissions. So it represents 72% of the midsole. And it enabled us to bring the footprint of the midsole down by 40%. And On will actually bring the first Clean Cloud shoe at scale commercially in fall/winter 26. So stay tuned. So On doesn't only make shoes, but we make also garments, and we make a tennis collection that's called the Pace. So here we launched the first capsule collection in 23. We expanded that collection in 24, and now we are broadening the range. So in that case, we use polyester to make the collection, and polyester is the main polymer we use for like sportswear textile. So here, we also use carbon emissions to make the ethylene part of the polyester, and we do that together with Lanzatech and Far Eastern. So yes, 20% thus of the garments are made from carbon emission, and we are 20% looks small, but we are very proud of this because it's a start, and we have some better things coming in the pipeline in my team. So there is people with different expertise in the innovation team. So some of us are working on helping to make products and phasing out from usage of virgin oil. So this is what I work on together with my colleagues. And another part of the team is working on revolutionizing the manufacturing processes. So a lot of them are designers, and I represent them today. I'm very honored to do that. And they are the one who kicked off and initiated these Lightspray projects. So let's quickly start with an introduction video.
For decades, running shoes have been made the same way.
So we challenged ourselves to break with convention.
The result is Lightspray.
A seamless high-performance upper, weighing just 30 grams, that reduces carbon emissions by up to 75%.
Lighter, faster, more sustainable.
Lighter than humanly possible.
Okay. So, yes, a robot that sprays a seamless upper directly onto a last, creating the lightest shoe we have ever made. So, On launched the first Cloud Boom Strike back on the famous Boston Marathon in 24. And this was our key athlete, Hélène Aubéry, who was wearing a pair. We actually customized the upper slightly to the shape of her feet because she has a wider feet than average, and she won the race that day. She then ran the race over the Paris Olympic Games in 24 for the marathon distance, where she arrived third, and she ran again the Boston Marathon this year, where she arrived second. So I think she proved that the shoe is helping her. So this unique process replaces the way we have been making uppers for decades. It's important to highlight that this single operation generates very, very limited amount of waste. So the conventional way we make shoe, we send yarns from a supplier to a textile supplier that then send this textile to a manufacturer. And during over all those steps, there is waste generated. And when we cut the upper shape on the textile, that can generate up to 30% of waste. So you can see that this is a pretty efficient way to make it. And this process takes only 3 minutes. So 3 minutes per shoe, thus 6 minutes per pair. So let's go now through the history, where the idea came from and how we made it that we are here today. So 2018, the beginning, one of our industrial designer, Johannes, had this idea over, probably most of you have seen that, those spider net Halloween decoration. It was like, hey, let's try to make a shoe from that. So in 2019, he started to play around with hot glue guns and make prototypes. In 2020, the first prototype was made where actually someone could run with it, and that generated a lot of excitement internally because that shoe lasted for 150 kilometers before to break. So 21, a bit more resources allocated to the project, a bit more hope that this is going to work. So we rented the first robots in-house to generate the prototypes in a more controlled way. In 2022, things accelerate, and our first athletes come to Zurich and try the shoes. 23, way more confidence also internally and big dreams that we can maybe bring that to the Olympics in Paris. So starting to shape some goals on how to make that work. And in July 24, we introduced the shoe to the Olympics. And Hélène ran with the shoe as well. So the process, now the technical bit of the presentation, my favorite, the one a bit more comfortable with. So looks very simple and intuitive, but there's actually a lot of disruptive steps in that process. On has applied for 7 patents around this technology, and I'm going to take you through a few of the steps to make that shoe right now. So first, the robot grabbed the last. The last is this red thing you see on the picture. It's what has the shape of a feet. That's where we normally shape the upper material to make the shoe. So there is a head that sprays a thermoplastic filament directly onto it, and we make then a layer of material. You have then a second robot that grabs that last, and the material is then cured. No, sorry, not cured, like prepared with UV and plasma in order to be printed by inkjet printing. To add color, branding, and decorate a bit the shoe. And then the last is released, and the Cloud Boom Strike Lightspray is made. So we are actually using thermoplastic for that. I think that's that's something that's relevant for you now to know how we can make this, and if you guys can help us to produce that in an even cleaner way. So we need thermoplastic material, so we can play with polyesters or copolymers because we need a bit of stretch, but TPEs, polyamides, TPUs, to make that. That also enable us to recycle it at the end of life. Yes. So if we zoom in, you can see that the filament is blown in a helix shape. So it's falling on it, and this repeat unit makes make the material in total. So it's a 1.5 kilometer long filament that's used. And this is also a bit of the secret recipe to find the correct grade to do that, because you want a polymer that's strong enough to have tenacity, tensile strength, but you also want something that's soft enough that when it falls on itself, it sticks to it and then it dries. So we have to identify what are the right materials to do that. So there is few advantage. The upper is very light. The one-step manufacturing process and the speed of the process make it that we don't use a lot of material, we don't use a lot of energy, and that enables us to cut the footprint of the upper by 75%, or in other words, 4.6 kilo of CO2 equivalent less per pair of shoe. On top of this, you understood there is not too much labor involved in this process, so we can also bring back the manufacturing of shoes closer to where the customers are. So right now, a lot of the shoe brands produce in Asia for this reason, for the cost of labor that's low. So with this process, we can also have a more a nearshoring approach in production. And our ultimate goal, so I mentioned it with the thermoplastic, would be to have a monomaterial shoe. We already, for the one who know the Cyclone shoe at On, we already released the shoe that was aiming at this monomateriality in order to be recycled. Because right now it's very hard to detach the upper from the bottom unit and to revalue those materials. So if we have same material on the bottom and the upper, we can then recycle everything together. So this is the breakdown of a traditional shoe on your right, up to 34 different parts. So you can see here what we call the vamp, the bigger part, which is the upper part of the upper. A lot of reinforcements, the tongue, straw balls, and of course the midsole components. And you can see also foams and tapes. That's all those things that we merged in one process. So the Cloud Boom Strike light spray contain only 7 parts. So in another way, here it's summarized how the process is classically followed. So as I said earlier, tier 3 yarn are made, then they are shipped to the fabric manufacturer, and those fabrics are sent. But we have different fabrics, we have different what we call trims, laces, bonding. We have what we call the heel counter, like all those different parts that have different function are put together, and that's 200 assembly steps in average. So that's a lot. I think you got the message. And now in few numbers to summarize all this. 3 minutes only to blow a upper that's 30 grams, and we can make a shoe that's 170 grams. We spray a 1.5 kilometer long filament, no glue, no seam, no straw ball, no sock liner. So this is what's normally between the upper and the midsole. So that also enables us to gain some weight here, and 75% reduction on the footprint side. So now we went through the history, the process, the impact, and I would like to say a few words on the design and what can we do with this process to enable designers to think a bit more freely and to play around. So you can imagine that the head that sprays the material, depending on the speed, will blow more or less material. So if the head moves slow, we will accumulate material in a zone, so it will create a reinforcement, less stretch, stronger and thicker material, so that's kind of going to block the fit in some area. And if you move the head faster, that will create open zones, mesh, that will enable to have breathability and more freedom to move. So conventionally, we seam we bond those materials together. And in that case, we can just seamlessly create those fading effects and design the upper in one go. So something also very nice is it really shortened the time necessary to create a prototype. So from an idea to the making, there is just a few hours, where normally you would have a drawing made by a designer that goes to Asia, that comes back, and there is different iterations. The designer can directly play around and make what they have in their mind. So there is a lot of computational design skills required to make that happen. Of course, advanced software and algorithm need to be part of the designing phase. So once the designer have been playing with new ideas, they also need some testers, and the advantage of working for a sport company is that we have a lot of testers to play with. So a lot of them like to volunteer to try those shoes, and we have them across different disciplines, so road, triathlon, and tracks, and no one better than them knows what they need to practice their sport. So they are very happy to give feedback and to help us to push the boundary of the technology. So together we can very customize the shoe according to what they need. So engineering a Lightspray shoe is playing with integrative design. As I said earlier, its complete manufacturing way and digital nature open new doors for the industry. So a few numbers of this epic adventure. We have right now 18 athletes who are competing with the Lightspray shoe. One bronze medal won by Ellen Obiri that you can see on the left. And when we released the shoe over the lab in Paris during the Olympic Games, that was received with a lot of success. And yeah, I think we counted up to 330 media articles on the topic. So the future, very nice concept. We kicked this off in Zurich, and now we need to ramp this up. So I can't disclose everything today, but I can tell you at least that there is. So there was already a solid team working on this project, and we hired a lot of new talent to support us to ramp this up. Very specific profiles, and everyone is working day and night. I don't know if I should say night, but at least days to make that happen at scale. So now it's all about scaling, developing, and expand. So personally, I truly believe that this process has the potential to revolutionize the sportswear industry, but not only. You can imagine that by spraying a metal on a 3D mold you can make anything that can be worn. So that has also the potential to disrupt many other industry. So thank you so much. If there is people who are interested to see, touch the shoe, we have a sample at our booth. So please stop by and drop questions. So thank you so much.